Tabitha the cat is trying to catch fish, and we're assuming that each attempt of catching the fish is independent from the previous one, and we're assuming that the chance of catching a fish stays the same at 0.12. The standard assumptions for the geometric probability is the same and independence. So if x equals the number of goes taken to catch a fish, it's a geometric, and so find the probability that Tabitha takes two attempts to catch a fish, probability x equals 2, and at least 3 greater than or equal to 3 down there. So I'll do both of those on the calculator. Going to my distribution mode, going to my geometric one, and the first one I want is equal to 2 with the probability 0.12, and so that's giving me 1056, and changing this now to a greater than or equal to, greater than or equal to 3, and that one there is 7744. Just write those down. And part C says find the expected value of the number of goes, so that's 1 over 0.12. 1 over 0.12 is 8.33 to 2 decimal places, and find the variance of the number of goes. So the variance of the number of goes is 1 minus 0.12, 0.88 over 0.12 squared, and that works out to be 61.11 to 2 decimal places. Once Tabitha has caught one fish, she tries to catch a second one. Find the probability that she needs 3 attempts to catch her first fish, so that's x equals 3 for the first one, and 3 further attempts to catch her second one. So I think that's just the probability of x equals 3 and another x equals 3. Let's get the calculator to do that. Change that back to an equals one there. So probably that it equaled 3 was 0.0929. Let's just look at that to see it. So it's 92928. And I think we just need to square that. Yeah, so just 92928 squared, and I'm getting that to be 0.083. Hang on, 1, 2, another 0. 0.0086356. That's quite small then, isn't it? 0.086. Let's just think about that. She wants to catch the first fish after 3 goes, and then another 3 goes for another one. So we don't got to do anything with 6 there, have we? They're just two different independent ones, catching 3 and catching another 3. Yeah, I'm happy with that. Part E then, find the probability she caught the first fish on the second attempt, so that's x is 2, and then also second fish on the 5th attempt. The 5th attempt just means another 3 goes, I think. That's just that then, isn't it? So miss and then successful there, and then miss and then miss and then successful again. So we know x is equal to 2, we had it earlier, so that's 0.1056, and we've just done x is equal to 3, so that one's that one there, 0.09292. And if I times those two things together, I'm getting 0.098. 9813 and so on. I think the other way of thinking about that, actually, I mean, I know what's happening here, don't I? I know that they're missing, so that they're failing once and then getting the next fish, and then failing again, and then failing again, and then getting the next fish. And I think if I just times all of those things together, I'm going to get that answer anyway.